Hello and welcome everyone, we're happy that we're all together again. In this tutorial we will talk about the directional protection. So fasten your belt and let's get started. The aim of this tutorial is to learn about a new important topic, which is the directional protection. So we need to know what is the directional protection and how it works efficiently to do its job of protecting the different components in the circuit. First of all, suppose we have that simple power network which has those two generators as power sources, and suppose we have a fault occurs at that position, for example, which is those transmission lines. So there may be a short circuit condition occurs at those transmission lines which makes that point to be a faulted one. Here at that case, as this network is handled as one closed circuit, this fault current will pass through the whole of the components in the circuit, and this means the fault current will reach the circuit breakers on the right hand of the faulted point, and it will reach also the circuit breakers on the left hand of the faulted point. But this is a problem, as if the fault current reaches all the points, this means all the protection systems will work to cut all the circuits. And this is an undesired condition, as we need the protection system to cut the faulty circuit only, which means we need those two circuit breakers to work to cut only the power at the transmission lines. So if we cut only the faulty circuit, we will maintain the reliability of the rest of the network, as the healthy parts will work with no problem. But you can ask now, how can we make the required circuit breaker on the faulty zone to work only, although the fault current will pass through all the network? Here to solve that problem we use what is called the directional protection, as the directional protection is a type of protection that is used to cut the faulty zone only, not all the zones in the power network. But how this is done, or how the directional protection can recognize a specific zone to cut it? Here we say that the protection system will have a specific direction that it will detect the fault current through it. For example, this protection system has that direction, which means it will recognize the current that passes through the left direction only, or it will see only the left part of the network. So if the current increases in the left direction or the left part of the network, this protection system will trip the circuit to cut it. While if any fault occurs at that right part of the network, this protection system will not cut the circuit anyway. And the same idea is applied to that protection system, hence its arrow direction goes towards the right part. And this means if any fault occurs at the right part of the network, this protection system will trip the circuit. While if any fault occurs at the left part, it will not detect the fault, as it detects only the fault on the right part. And this protection system also detects the fault on the right hand only, while it neglects the fault on the left hand, and so on for that protection system. It detects the fault on the right hand, and also the same thing for that last protection system, it detects the fault on the left hand only. Or in other words, we can say that the protection system breaks the out of path faults, which are the faults that has the current direction out of the path, while it neglects the faults which happens towards the path. But a deeper question now is that how the directional protection detects the direction of the fault current. So we need to know how the protection system recognizes the direction of the current when it passes through the network. Very easily we say that at the normal case, when the current passes through its forward direction, there will be a phase shift between the current waveform and the voltage waveform, which makes the voltage signal to lag the current signal with about 20 till 30 degrees. And the lag means that the voltage signal precedes the current signal, or the voltage signal comes before the current signal by about 20 or 30 degrees. And here this is the phasor diagram of the voltage and the current signals. We can note easily that the voltage signal for the phase A, for example, becomes before the current signal by 20 degrees. So this is in case of the current moves in the forward direction. But suppose the current reverses its direction. Here at that case, the current will lead the voltage, and the lead means that the current signal will become before the voltage signal, or it precedes the voltage signal. And it appears here in that phasor diagram. At that case of reversing the current signal, we find the current vector for the phase A, for example, to appear before the voltage signal for the same phase A. So what we want to say is that the protection system will detect the voltage and the current signals, and it will sense which one precedes the other, and by that way the protection system will detect the direction of the current, is it forward or reverse. And after that, the protection system will work to trip the circuit if the current is out of the path, while it will not break the circuit if the current is towards the path. And if we applied that concept on the previous example, if the fault occurs in the transmission lines at that position here, this protection system will find the current to be out of its path as the current becomes after the voltage signal, so this protection system will work to trip the circuit. But on the other hand, this protection system will not work, or it will not trip the circuit, as it will find the current to have a reverse direction as it leads the voltage, or it becomes before the voltage. Hence, it will not work as the two protection systems has a different direction for the current passing through them. And this is the idea behind the directional protection, to detect the required zone at which we will detect the fault to trip the circuit. More than great. So that's about this tutorial at which we explained the directional protection. Hope that's clear right now. Thank you for watching and see you in next tutorials.